looping in Grasshopper is nearly impossible without having an external application or plugin, whatever you want to call it, so iHome or Snake or whatever. Now, we can do that with Python and C#, but I'm not teaching you C#, so we're going to do it using Python. Actually, C# is much easier. But I found a way to do it in Python, so we're going to do it that way. And then we're going to create a bunch of random walking people in a space, and we can put money. No, that's not money. But we're gonna put bets on who's going to arrive first at the end. We're going to build a race. Why not? It's just going to be a little bit of fun. Oh, and they leave a nice little trail behind and stuff. Right, cool. Oh, you started the recording? Mm-hmm. Where's Nick? All the way down there? Fine, just stay there. No, I don't want you here. Yeah, it's fine. It's fine. Just stay down there. It's okay. It's cool. Right, okay. So, for loops. What is it? So, in a nutshell, for loops allows us to loop over a collection of items. So, if you all recall what we were doing last week in terms of this statement, and for the people who weren't there, we're using logical statements in Python that basically say, if this, then this. If the value of the item that I want is greater than 50, then print out the value is greater than 50. Right? There's a logic statement, it has a start, it has a finish, and it just does, it executes it once. That's it. The for loop is quite interesting because I can tell it to execute a command over and over and over again as many times as I tell it, as many loops as I want it to do. So I can tell it to loop 50 times, so print I love rock and roll 50 times. I don't know why you would want to do that, but you can with the loop. And you don't have to write print I love rock and roll 50 times. Just tell it to do it once for 50 times. But you can use it for a few interesting things as well that we're going to learn. And it's actually one of the most useful things you're going to learn in Python, how to loop. So how do you code it? Can you all go into Grasshopper for a second? And actually, I'll go as well, so you're not feeling lonely. One sec. That's good. That just Grasshopper. Right. Okay. No, you can't stay halfway there. Right. Okay. So for people who haven't been here before, if we double click inside our empty space and we type in py or Python, we get this called a GH Python script. That's what allows us to code Python in Grasshopper, okay? All you have to do is just press enter and then you have this thing here. Good, it's a good start. For everyone who was here last week, I hope you remember how to do this at least. Otherwise it wasn't a very good session. Right, so if you double click it, it opens up our script editor. So, how do we code a for loop? Well, we basically say for something. In this case, we'll create a list. A list is similar to a shopping list, let's call it. Let's just put points now. We'll go into here. Oh, let me save that for a second. We'll go into here. We'll go and create a point. There we go.
and we'll just make a bunch of points. You select all that, right click, set multiple points. Okay, so this is a list, okay? A list contains a collection of data. In this case, our list contains, I made 6 points. Could be as many points as you want. Okay, so if I plug it into X here as an input, and I actually right click on X, see if you remember this thing. What do I need to tell Python here about our input? Sorry? Not flat, no. We're not gonna flat. What type thing is? Okay, so what is it? I have to tell it, okay, so this thing that I'm giving you, it's a specific thing, right? It's a specific data. What is it? In our case, what is it? Yeah, the point 3D, right? It's a collection of points. So it's just point 3D. So if we go up here, and we press point 3D. There's one more thing we need to tell it. What did I say that this is? It's a list, right? Item means that it's one single piece of information. In this case, it's not, it's a list. Tree access, who here has been to Mahmoud's workshop, ADD workshop, where he was talking about trees, managing trees and branches? Okay, 4 people. Okay, cool. A tree is basically a list within a list. So if you think about our collection of points, we have 6 points being one list. A list within a list would be, we have 6 lists, each list contains 6 points. So in total we have 36 points, but they're divided into 6 lists, right? So that would be a tree. So if you think about a tree that has branches, and those branches have branches, and those branches have branches, it's kind of like that. We're gonna go through how to access it in Python, which is quite interesting. You might find it useful. But for now, all you have to do is just tell it that this is a list. So now it knows it's a list. It knows that it's point 3D. So if I go here as an output and just say, and just tell it, okay, so my output A is equal to X, and press play. There you go. Now our points of output are 6 points. Now we're not going to do that. We're just going to do a for loop, okay? So how do we do a for loop? Well, we can say for every item in X, so for every item in our list, which is the input X, we can name the list whatever we want, right? It's just X at the moment, and we can also name this variable whatever we want. Just to make it clear, as I said, it could be I, it could be J, it could be pineapples, it could be Bob, it could be whatever you want to name it. It doesn't really matter as long as you know that that is the reference that you give it. Now, we need to indent, which automatically happens. So for every item in X, I want you to do something. Okay, let's do something kind of cool. Import rhino.geometry as RG. Right, so I'm just telling it to so what is this? Rhino geometry as RG basically means that I am importing the commands that you would usually use in Rhino to create a geometry in the Python script here. There's a couple of imports you can do that are quite useful, but this one's one of them. But I just want to have a little bit of fun. So for every item in there, I want you to append. What does append do? Extends it by 1, adds 1 item to the end of the list. I will say that the A is an empty list. For those of you who don't know, there is a video online about last week, so it will make much more sense if you see that afterwards. But those square brackets indicate that I'm creating a list. I can put things in a list. In this case, I'm saying that the list is empty. because I'm not putting anything in there. But I'm looping through and saying that A dot append rg dot whoops rg dot okay, rg doesn't have it, so it will be rs dot, does rs have it? Yeah, there you go, rs dot move object, that's what we want. Open brackets, because it's a function, and the function wants a list of 3 numbers or vectors and the object. So the object would be the item. So we'll grab the item and rg.vector 3D five, comma 5, comma 5. I'll explain what I'm doing in a second.
That's the problem. Well, this thing. So when you put rs dot, it should come up with whatever you want to select. So if you select move object, it will tell you exactly what it needs. In this case, it says, well, I think it's vector of 3D, so it tells me that I need 3 things. I need the value of x, y, and z for the vector.
Right, okay. This is just for us to do a little bit of test. I'm not going to explain everything fully in a second, but what essentially happens, you can see it here. Our points move up by 5, right by 5, and in by 5. So x, y, and z. Okay, so let's explain what we've done. I'm going to go back to basic, don't worry. But essentially, I said that A is equal to an empty list. So our output A, which is here, whoa, come here. Our output A is an empty list. There's nothing in it at the moment, but I told it specifically that it's a list so I can manipulate it like a list. Then I said, I created the for loop, and I said for every item in X, so for every point that we have in our initial input of X, it's going through the list, point by point, right? A to that end, which just means that add this, whatever I'm telling it here, into my list of A. A to that end, rs dot move object. Rs is a random script syntax, so that is a command. So the move command is Rhino. I'm telling it to do the move command in Rhino. And it's telling me, okay, I want the item and where it's going. The item is item. If I was to name this I or Y or point in X, they'll just be points. So this is the reference, right? So every time it's looking through it, it's referencing whatever that is in here. Okay, so the first iteration will take the first point in X and it'll go, okay, I'm going to move it by a factor of 555 on the X, Y, and Z and put it in the list. Then it goes to the second point, so the second item, and it goes, I'm going to do the same thing. And then the third item, and fourth item, and so it goes the entire list. Because I'm telling it to do for every item on it. Does that make sense? Kind of? And you can see, like, look, move everything. I know you can't see the on the X, Y, and the Z. We moved it by 555. If I was to change the Z direction by, I don't know, 15 and press play, there you go. See, they've all climbed upwards. So, this is just a little introduction on how to use it here. Now we're going to go back to our explanation. Right, as I said, so how do we code a for loop? For whatever the variable is in collections, whatever the list is, do something, right?
In our case, I said for every point in our collection, which was x, append it to the output and move it. That was what I told it to do. Try writing this. Create a new Python node within Grasshopper. Then double click, press Python. Just create a new Python node, similar to what I did before. Yeah, everyone done that? Ready? I need to make sure that everyone's ready in Python. We're going to write this down. A is equal to an empty list, so 2 square brackets. And then for letter in, write Giraffe Academy with quotation marks, and then up and down colon, presenter, indent, a.append, letter. Tell me what happens when you press, if you put a panel name, what happens? Connect a panel to it. No. That was just so I can get the point 3D. Yes. Where's the, you're plugging something to the output? There you go. Excellent. So you've done it. Right. Has everyone done this? Yeah? Hands up if you haven't, will help. No, everyone's cool with it. Okay, so why didn't we need to tell Python what letter is as a variable? No, previously, if you remember from last week, every time we had to create a variable, we have to say letter is equal to some. In this case, we're just saying for letter in Giraffe Academy, so we're not really telling it what that variable is. Why didn't we need to set it up? Well, look at the answer here. Well, essentially, you are creating a variable, and the variable is automatically equal to the item on the list that's going, right? So whatever the item on the list is, in terms of the first loop will be the first item on the list, the second loop will be the second item on the list, right? So letter is equal to that item automatically. Next. Right, let's see how we do it. I want you to create a list of friends and add 4 of your friends' names on the list. Add 4 people you wish you had as friends on the list. Sad existence. Just, go on Facebook, whoever you've been stalking, just add their names there, whatever. I'm not that fast. And create a for loop that for every friend in the list of friends, it appends the name of the friend from list A. So, how do we create a list? Let's do this together. I don't want people have to create 4. I created A as a list. In the previous one, we said A is an empty list, but now the list is going to have to be. How do we create a list? No, I'm just asking generally. Yes, square brackets. Where's my mouse? No, I don't want it to be here. I need to be here, as you were. There you go. Okay, cool. So, let's do it together. In Python, and I'm going to say, okay, it's a list of friends. So, misspelled it. Friends is equal to a list. I want to add things into the list. The way you can do that is just write what it is. Tom, Bob, Jerry. These okay names for you? Sorry? You do put quotation marks, yes.
Tom, Bod, Jerry, and so on and so forth. Which one? The other one? Jenny. There you go. Nice generic sounding names. Now, these are obviously strings as data types, so we need to put them in quotation marks. Jenny, you're in quotation marks, and so is Jerry. Okay, so there's our list of friends. So the task now, let's go back to the task. Sorry. Is to create a loop. So we're going to create a for loop that for every friend in our list of friends, it will append the name of the friend in list A. For every friend in list of friends, append the name of the friend in list A. Try it.
Remember?
Sure.
Well, in the beginning, you remember it was the 4 item, but now it's going to be, it's not a letter, it's an item.
Doesn't matter. Whatever you need, the variable is irrelevant.
A column, a window, anything.
Anything.
Ah, I see.
Done? Are you ready? What are you doing? Okay, remember that you need to signify before all of this that A is equal to an empty list. Otherwise, it's just not going to figure it out. Come on, you can do it.
There's no licenses.
There's no more licenses.
There is a problem with the license. Yeah, I need to explain it and see what's going on.
So how many people here have no access to it? How many people here are not following?
Guys, I know many of you are struggling currently to get the licenses. So, like, who doesn't have access to Rhino at the moment? Licenses issues. Now, no one, but if you will come home, you'll see.
No one.
So everyone has access to Rhino is following. Are you? All good with Rhino over there? No.
Okay. So,
Well, anyway, that's something I'll probably deal with. So I'm going to send an emergency email again.
can we do?
Maybe they can pair up. Yeah.
Yeah, can you pair up with someone here?
Yeah, just pair up with someone.
Pair up because it's a shame to miss the lesson just because of that.
Maybe one of you is like taking notes.
I'm not doing that much.
Yeah.
So, guys, you've been asking where is your following the
It's the way that you input it into the panel. We have to signify that it's a list.
It has to be in there. Especially now that we have strings that are licenses here, we're using the Rhino license. That other people cannot use. Please save your file. Right? This is the last warning. Please save your file. Now.
Right. Okay. We're gonna go to the answer. we're gonna be done by 5. So after 5, you can come back in.
Every single computer and especially because the license is issued, we don't have like people wanting to write license to art. So now this is already being disrupting the session enough. Right, so it's the last time. Just by like a couple days ago, Thomas, our friend, please, it's just like a couple of hours and we'll get to all this stuff. Like, it's not it's 2 days, right? No.
It's only for a couple of hours, right? So it's not really.
Yeah, I mean, it wasn't like that.
Okay, guys, let's move on to the answer. A is equal to an empty list. We must always define what our output is because otherwise Python is just not that smart in understanding what we're doing. Right? So A is equal to an empty list. We create our list of friends as I did before. Friends is equal to open brackets Jim, Karen, and Kevin. I added only 3 here. I don't know, but there you go. And then for friends, for friend in friends, A dot append friend. No, the name of the list is called friends. So the first one doesn't matter. I can say for I in friends, or Y in friends, or whatever name you want to give it in friends. Friends, the variable friends can have whatever name you want. I just use it because it's just easier, right? For friend in friends, it just kind of makes sense. Yeah, that's how you would be. That's how you would use it to loop. Does everyone got that? Yeah. Yeah. Does anyone want any help? We can come and sort of help out. Let me help.
I'm just thinking how to do it. And I know how long the last maybe after the hours, like you find me, you can bring back the mic to me. I'm gonna be at this now. Yeah. Yeah. If you don't need it, it's fine. No worries. Yeah. What time are you it should be fine. In theory, I'm able to come back and or anyway, when you need trade upstairs with the CPU for now. Tomorrow morning would be teach. Yeah.
Sometimes it's very
if there is any question about
cool. Guys, don't forget your colons after you write the for loop, because it basically signifies that once you have a colon, everything underneath here is what you do when this happens. It's the same with an if statement. Okay, other examples. Okay, let's write a few other examples. What about if we write for index in range 10, A dot append index? What does that do? Write it down. It's not about plural, it's about the name. People. People will be people. Right, okay guys, for index in range 10, A dot append index, what does that do? Come on, tell me. Just add it underneath whatever you've done. Okay, let's make it easier. Instead of A dot append index, just say print index. Just type in print space index. Tell me what happens. Underneath, you should see some stuff.
Come on, write down. You have to write that for index in range 10, a dot of 20. All right, let's do it together.
Must be done.
Let's do it together. You read a red box, you shouldn't be getting a red box. So, why are you not allowing me to do this? There you go. Right, let's do this. Wait, what did I say? What was the, for index in range, wait, what did I say? For index in range 10, okay. For index in range, or index in range, open brackets 10, print index. All right, any bets on what's going to happen? Let's see. What do we have here? Come on. What do we have here? Yes, we have a list going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Why? Because I'm telling it to print for range of 10, so for at the amount of 10, print the index at every point. Okay, if the range was 20, what would happen? What would happen if I have range of 20? Same thing, except it'll go up to 20. 19, because 0 counts as the index of 1. Can everyone hear me down there? Yeah? Okay, cool. Right, second one. Now that you know what we need to do, for index in range 3 to 10, print index, what happens? Any bets? Come on, give me some bets. What's going to happen, you think? For index in range 3 to 10, what's going to happen? So, what happens? We have 3, 4, 5, 6, 7, 8, 9. Why? Zero is still the first one, so I'm telling it to go after the third index, which would be the number 2, until and including the 10th index. No, after. So you'll be 3 to 10. Cool. So we can do that, right? Let's look at the next one. I'll be another example. For index in range length of friends. 8 dot append. Oh, this is an interesting one. I'm gonna have to copy the whole thing. Right, so I have friends here. A is equal to an empty list. And then we'll put a panel at the end of this so we can see what's happening. Connect the panel up. Very difficult to do when you're looking at the screen. Okay, so let's try it out. Right, for index in range of length of friends, A dot append friends index in square brackets. What am I doing? Come on, someone. Thoughts before I press play. Yeah, kind of. Kind of. Come on. Did anyone do it? Well, what's the answer? What happens? What comes out in the panel? Let's press play. You guys are not very interactive. This is not very fun. Get your shit together. Right, so so we get Tom, Bob, Jerry, and Jenny. Basically every item on the list. Why? Why are we getting that? Because I'm telling you, for every item in range of the length of friends, basically what I'm saying is, for every item, for every item in range of length of x, that's an interesting one. Because usually, previously we do range of 10, right? So we do a loop through 10 things, right? In this case, I'm just telling it to loop through whatever the length of the list of friends is. What's the length of the list? If I have 4 friends here, 4 items in the list, what's the length? What's the length of the list? 4. Yes, it has 4 items. The length is 4, right? So I'm telling it to do for index in range of 4. It could be the same. A.append friends index. What does that do? People who were here last week, remember when we were playing indexes? No? It's been a week, right? A.append means add to our output A from the list of friends that index. And the index changes every time because it's going through the whole list. It starts with 0, so we go friends 0. Friends 0 is the first item on the list of friends, which would be Tom, right? What if we wanted to do, let's try something different. The index times -1. What happens? What happens if I do this? The index times -1. Well, yeah, I mean, we have Tom, Jenny, Jerry, and Bob. The list is Tom, Bob, Jerry, and Jenny. Why is Tom still first?
To start on 0.
Yeah, because 0 times -1 is still 0. Right? So it's still going with 0, and then it's going, okay, now it's index 1. 1 times -1 means -1. -1 index is the last item on the list, so Jenny goes second. And then it goes 2 times -1, which is -2. This item, which is, -2 is Jerry. So it's going -1, -2. And then it's going 3, which is the last item on the list, times -1, which is -3, which goes to Bob. Oh, come on, that's just kind of fun. You get to play around with things, guys. You have to be a little bit innovative. Right, okay, let's move on. Looping through, so what do we use it? We can use it to loop through an array, loop through strings, loop through a range of numbers. We're going to use it once or twice in the examples I'm going to give you. But let's see if you understood how to for loop. Create a for loop for an index in range of 5. You usually write this down. So a for loop for an index in range of 5. Within the for loop, create an if statement so that if the index is equal to the number 0, it prints first iteration. If it is equal to the number 1, it prints second iteration, and so on and so forth for every index until the last iteration. So, how do we write a for loop? How do we write a for loop for an index in range of 5? So, we here have like 5 examples. For index in range open brackets 5. Right, so once you have that, within that for loop, You need to write an if statement. Hands up who doesn't know how to write an if statement. It's fine. Just hands up who doesn't know how to write it. I expect you guys to skip it for now. Just create the for loop. We'll do it together. Let's see. I'll give you another couple of minutes for the people who do know how to write an if statement. But it's pretty simple. If the index is equal to 0, then print first iteration. Print 0. There you go, 0. Oh, that's just for the first. Yeah? You have notes. You took notes. I'm so proud. Right, another minute and then I'll show you guys the answer.
Oh, like I understand it, but I just don't know.
It's fine. So we'll look at this. Not do 0 to 5. Right. Okay, good. Yeah, what about the rest? Ellie. Ellie. Also, you don't need to do if, you do if, any. Right, okay. No. Why do we use, so this is the answer, by the way. I can zoom in so you can see it a little bit better, hopefully. Hang on. There we go. So, why do we use elif instead of just if? If you use if, what it'll do is, you'll go through the if statement, you'll execute it, you'll go to the next if statement, you'll execute it, you'll go to the next if statement, you'll execute it, and so on and so forth. That's not what we want. Because we want to do if, elif, so if, elif, else, because when you do elif, it runs this as just once. They go, if this is true, then I do it, that's it, stop. I don't care what's written afterwards. If this is not true, I move to the second one. If this is not true, I move to the third one. If this is true, I do it, I don't care what's written afterwards. Does that make sense? Yes, up until the point that is true, afterwards it just stops. If you keep having if, you might end up having a statement that's true here and a statement that's true there. It'll run both of them. But I'm not necessarily what you want, but if you want that, then you do. But in this case, I just wanted to do one sequence of events. So for the people who weren't here last week, this is how we write an if statement. If, in this case, index, which is our variable, is equal. The reason why we use two equals is the way that the syntax works, because if we use just one, it's just signifying that the index has a value of 0. Whereas if we do equals, it's checking if the index is equal to 0. It's just how the syntax is written. So if index equals 0, you have the colon, and then indent, do something. In this case, print first iteration. Elif is, as I said, continuing on from that one. Good, I think that's the last slide in terms of for loops, right? Yes, okay, that's the last slide for loops. Cool, now we get to do something fun. Everyone's got that down? Yeah?
Index or negative?
The index can be negative. Negative index means that you're counting backwards. So -1 will be the last item on the list. -2, second to last, and so on and so forth. Right. Okay. Enough of this. Enough of the boring stuff. Let's do something a little bit more fun. Literally. So let's exit this. Let's bring. Sorry, just have to bring this in. How do you close it?
Oh, it's uses indentation. You don't close it, you just bring the indentation back. We can do exit as a method as well.
That's it. Once you exit indentation, then it's done.
Yeah, Python's great. Python's very easy. Right, so you see this lovely little thing here? We're going to create it. And you guys are going to create it however you want, but I'm going to give you the way in which you can do it. First of all, in Rhino, I want you to create a complex circuit. What's a complex circuit? Well, let's do it together. We can create, let's move on from that. We can get this tool, not the polyline tool, the one next to it. Sorry. There we go. And just create a squiggly line, however squiggly you want it to be. Press enter. Where's my line? What's happening? Why didn't you create it? Okay, let's try that one again. Is it just me? I can't see it. Oh no, it's there. I'm just creating it on a weird angle. Okay, I see. Yes. Let's go into the top view. Because obviously, it's doing whatever it wants. Cool. So, what's happening here? Ugh. We always end up with this thing in the bottom. No, not sure. Right, we can just copy it upwards. I'm sure. I'm just going to copy it upwards, just rotate it a little bit, whatever, and what is happening? Sorry, something's wrong with mine. Or I'm just not very good at looking at it. There we go. What happened to the previous one underneath? Still there. So if I select these two, just loft it. Okay, there we go. Loft. So now I have a complex surface, which for whatever reason is doing some weird stuff. Is this showing the normals? Is that what it is? Not sure. Right, just create a weird looking surface like that and then reference it in here. Okay? Reference it in Grasshopper. I don't know why this is happening with mine, but it is what it is. Why are these things projected? I don't know. It's gone off the threads. Hey, oh, cool. You created a complex surface. You created a complex surface. That's a very complex surface. Good. Don't worry about it. Just create a complex surface. Is it enough? Yes. Okay. Come. You need a help as well. So we create those two. Just select both of them and type in loft. Present. And okay. Oh. They're on the same thing.
I'm good. Oh,
No, I'm not.
And when you the sketch original.
Oh,
original.
yeah, from sketch. There we go.
I can't use that.
you can.
But I have it already. So I've done a really basic sketch. How long will it cost? All of the surfaces are like perfectly.
Are they definitely? So it's what-
Okay, so does anyone else need help?
It's basically water type. Yeah.
Just export
DWG.
Yeah.
Yeah.
When I do that, it doesn't have like surfaces, it just has like the wireframe.
Are you sure?
Yeah, but and I wasn't shaking.
Yeah.
I'll
think
check with that.
it
That's
must,
good, yeah.
I think it must be an option in SketchUp.
Well, I think it's actually, I think it's an option when I import it, right?
Right.
When I export it.
This is on the other.
No, something like that. I'll show you after.
Right.
After,
Yes.
because otherwise, okay, just check it. Yeah. I was just checking the whole new site.
Last time I was using SketchUp was this year.
But you know when you, yeah, I don't think it's not the export, it's
Yes.
right, when I import it.
Excellent. Does everyone have a complex surface?
Try to express that.
You don't have a complex surface?
I just have a square.
It's still fine. It doesn't have to be complex. You're just a little bit square as a person. You want some help with the complex surface?
Yeah, let's do that.
You want to control the point. Right, okay, so everyone have a complex surface. You have complex surface, you have complex surface. The people over there have complex surface, you do? Yes, excellent. You on, your hands? Yeah, at least it's complex. Right, okay. So, what are we going to do with our complex surface? Well, we're going to create a Python node. First of all, can you right-click and put reparameterize on it? So, well, actually, no. What you need to do is just create a surface like this. Surface node on Grasshopper and reference it in. So select it and just press right-click and set one surface and just set it as a surface reference. And then when you do that, right-click on it on the left side, right-click on it and select reparameterize because it's recalculating some things. And we want that to make sure that it's aligned correctly. So sometimes when you loft or do something, the normals are pointing in different directions. We want to reparameterize so that it's It does a couple of other things as well. It fixes the U and V values basically in a way that just makes a little bit more sense. Now, we're going to create two sliders. One, well, you can do whatever values you want with it, right? So in this case, don't worry about naming the sliders. We don't care about that. That's irrelevant. Just put a couple of number sliders, and that's the way that we're going to divide up our surface. If you want to divide it up by 10 by 10, do it that way. If you want to divide it up by 20 by 50, do it that way. Whatever it is, however you want to divide up your surface in terms of the vertical versus the horizontals, just put the numbers there. We can change the sliders as we go along. I'll show you what I mean. So as you can see in the example here, if I was to increase this, what's happening? Yes, it divides it more on the vertical. If I do it here, it divides it more on the horizontal. Yeah, let's not crash it. Right. Okay, cool. Everyone with me? Yeah, you created two sliders? Those two sliders? You just open up this and you just type whatever number you want. So let's say 20 and press, well, I don't know, 30 and press enter. Done.
We'll basically make one divide surface.
Yes, we're going to divide the surface however we want in Python, and then we're going to create a set number of panels. So each one of these is made up of 3 panels, almost like a facade element, and which is going to be directly linked to that quadrant that we're dividing it up, so that if we change the surface however we want, we can manipulate the surface. So if I was to select the surface in Rhino, okay, it doesn't have the points on, but we can do that, P on. And if I was to manipulate this, right, if I was to move it like this, it'll reparameterize and create a component to fit the size of that quadrant, okay? So it automatically does it for you. So if you are to create a very complex facade, this is the way you can do it, and you can test around the size of the facade. So now, if I wanted to, I could run the output of this component through a genetic algorithm, which we can do, and we can have a little bit of fun doing that, which changes the size of the facades to make sure that the surface underneath gets more or less sunlight. This particular thing. We can divide surface using Grasshopper vanilla, yes. But creating a component at each one of these, technically, yes, depends on how complex you want to make it. if you want total freedom in terms of the complexity, Python is the way to go. Trust me. Also, I'm doing all this with just that, right? I don't have to have hundreds and hundreds of nodes running and considering and having to graft all the information and dealing with trees and data trees. No, just this little script right there. Done.
But there is no any benefit in terms of like computing efficiency, is it?
This is much more efficient.
Is it? Why?
Well, if I was to have hundreds of nodes running at the same time versus one,
They're not.
if you were to recreate this using Python nodes, which I'm not entirely sure you can do, by the way. If you could do that, then you would be running a lot more calculations because every node has its own processing time
Yeah.
and just adds up over time. Versus this is just one node that's executing one script.
Fair enough.
Otherwise, you can also do it in script.
Yes, each node is Grasshopper is essentially its own script, right? That's running and running and running and running. Now, of course, what you're asking it to run, if it's destroying the line, is much less computationally hard or heavy than just the Python node, but it adds up over time, right? So there is an efficiency aspect. Also, as I said, if you want to create something very complex, you need Python because you will not be able to do it natively on Grasshopper. It has limitations, right? It has nodes, and those nodes are limited in terms of what it allows you to do. Look, this is just an example. You can do a lot more things with it. And we're going to try it, and you'll see. We're going to run a race course first. Oh. Yes. Right, okay, so everyone with me so far? Right, so we're going to create a Python node that we're going to join everything up together. Use the names surf, unum, and venum. You can use whatever you want, but because they're referenced that way within the script, just use these names. Also, for the surface, it needs to be an item and needs to be type hint, obviously surface, right? We need to tell it that it's a surface that's coming in. So if you right-click on surf, or you can change the name up here, by the way, to surf, if it's X or whatever it is there. And if you go, it's an item. And if you go into type hint, just select surface. Okay, and then you do the same thing for the others, where unum is basically an item and it is a integer, so it's a number, and same for venum. Just set them up as what they are.
I mean, they went from downstairs.
Yeah.
Yeah. The three one.
Yes.
Yeah.
Sure. They would take a lot longer down there. Like a break in between the break.
They might. Such a weird way around. It's like, imagine you read my language, you should understand.
Yeah, it is basically. It's like writing. It's just like I realized there's this part here that's supposed to add it.
Oh yeah, it should be like a square bracket.
Yeah. So when I'm doing the index part, it's just it's just so, yeah. If we're doing this in C#, you can do C#.
Okay. Right. Everyone have that? Right. Okay. We're gonna start a little bit of fun now. Let's not get too bogged down with this. Let's start slowly. Right. Let's make it this way. So, the first thing we want to do is write import rhino.geometry as RG. Basically, we're going to be using some components that are within Rhino geometry, so we need to have that. We need to have that referenced. Okay. Remember how I did the vectors? I imported the vectors. It's the same thing. We're going to need it.
What RG stands for?
Sorry.
What RG stands for?
RG is just the name that I give it so that I can quickly reference it. I could just in the code write rhino.geometry. Whatever it is that I want in there, like move object or vector 3D or line, whatever it is. But to make it easier on myself, I just write RG dot whatever. Okay? So it's just a shorthand of rhino.geometry.
You can call it anything.
You can call it anything.
You can call it Oli.
Yeah.
But then rather than writing rhino.geometry dot, whatever,
write Oli
use Oli
dot.
dot. It's just
Or
shorthand.
just, both dot. Whatever it is that you want. We just put RG because, Rhino geometry is shorthand RG. Just makes it easier for us to understand. Okay, right, so once you do that, then we need to create panels on this surface, right? So before we create the panels, we're going to create an empty list called panels, so we can store them in there, right? So we're going to go panels is equal to an empty list, right? We're going to create this list of panels. Everyone with me so far? Yes? Okay, now let's get a little more busy. Now we're going to do a for loop. So, what are we trying to achieve? We want to divide our surface, right? And we want to divide our surface based on our u and v values. So based on the two numbers that we brought in, right? The horizontal and vertical division. So we have to do, and then for each one of those quadrants where that u and v value exists, we want to add a certain number of panels in order to create our shape. Okay? So we need to access this division, and we need to access it in terms of, I think I have to draw it. It might be easy. So, do we have a whiteboard by any chance? No, no boards. Is there paint on this? Go paperless. Go paperless, okay. Yeah. Oh, we have a whiteboard. Okay. Reggie, go upstairs, get a pen. Please. Please.
Why just use whiteboard? I didn't see it.
Oh, where's the whiteboard in Microsoft?
You go to start. You're leading this. Start. Oh, cool. Do you have like a drawing?
I've never used
program?
it. Never used it.
Just like a drawing program. Paint. You have Paint? I don't know what that is.
It's not Paint. Freeform.
Freeform, that
Maybe
looks-
that's something. Yeah.
Yeah, that looks about right.
Enable iCloud sync. No. All right, let's just make a new one of these. Whatever that is. Can I draw it? Where's the drawing? No. It's two. Where is it?
Above the drawing.
Where are you? This one. All right, fine. Screw it. I'll do it this way. Right, so we have our surface, right? And we're going to divide our surface based on the number of divisions that we have. Let's do a Control-C, Control-V. There we go, like this. Now, they're equally divided, by the way. This is not to scale. So don't crucify me on this. Right, okay, there we go. And we also have some vertical lines as well. Vertical divisions. There we go, like that. And it's moving upwards. Cool. Okay, so. Can you see it? Can you not see it? Can everyone see this? Right? Now, let's think about it this way. I have this surface that I'm dividing accordingly, right? I want to create a panel in each one of these. So when coding this, I need to say, I want to access this part, and this part, and this part, and this part. What's this? What's the index of this? If it was a list, it would be the first panel. But I have a U and V value. So if we think about it in terms of a U and V value, if we think about a column being U value or index 0 in this direction, and index 0 in this direction, what would be the combined index of this? It would be index 0, 1, yeah, 0, 1, and then 0, 2, and then 0, 3, and then 1, 0, 1, 1, 1, 2, 1, 3, right? So in order for me to sort of access it, I have to do two for loops. I have to say, for every item in here, and then for every item in here. So what it'll do is, it'll start looping through this loop, go 1, 2, and then it'll finish and move on to the next one and go 1, 2. And then finish, move on to the next one, go 1, 2. Finish, go to the next one, 1, 2. So we have a for loop within a for loop. Does that make sense? I can explain it again. So we're going to create two for loops because I want to access every single one of these components. If I only had one for loop, because they're divided in two different directions, it'll just go 1, 2, 3, 4 in one direction, and it'll end the loop. Okay? But I want to access every single one of them, so I have to do a for loop in that direction and a for loop in this direction. So I go for every item in this, so we'll go for item 1, 2, 3, 4. For every item that's under this index, so 1, 2, then move on to the next one, 1, 2, and 2, and 2. Okay, so it's coordinates on a graph, right? How do you get coordinates? I can't just give you the x, I have to give you the y, right? If I only create one loop, then it's just iterating across 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. If I give it another for loop, it'll iterate through 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, and move on to 1, 1, 1, 2, 1, 3, 1, 4, and then move on to 2, 3, 2, so on and so forth. So 2, 0, 2, 1, 3, and so on. So it's kind of like telling it to access every point on a 2-dimensional. If we had a 3-dimensional, if we had a z-axis, what would be the difference?
You have 3.
And another for loop, yes. There'll be a for loop within a for loop within a for loop, because it's not just going to go in, like we have now, 1, 1, 1, 1, 1, 1, 1, 1. We'll go 1, 1, 1, 1, 1, up, 1, 1, 1, 1, 1, up, 1, 1, 1, 1, 1, and when it's done with that, 1, 1, 1, 1, 1. So it's going 3 dimensions. It's 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3, 0, and so on and so forth, right? So the for loops allows us to, if we do a for loop within a for loop, allows us to have a second dimension. Yes?
You have 4.
And just breaking the barriers. You could technically, but in terms of a spatial dimension, there is no fourth dimension.
You have time.
We
Where
have
is
time, I guess, you can have a
before
temporal dimension.
where
yeah.
that point is in X, Y, Z at a certain.
Yeah, at a certain point, you could do that, but I don't think you'll ever do it. So, in a 3-dimensional object, so if you have a bread, for example, and we break that up, a box or something, we break it up in a 3-dimensional object, you can do a for loop, in a for loop, in a for loop, in order to access every single one of those squares. In our case, it's a 2-dimensional surface. 2-dimensional has an x and a y coordinate, right? So we need the for loop in a for loop. So we access both of those dimensions. Does that make sense? Cool. So that's what we're doing. So we are creating the first for loop. So we're saying for I in range of unum, which is our 1 dimension, and then for j in range of v now. Now, I and j could be whatever you want, right? It could be, Bob and Mary. I don't care. It's just what the variable is. we use I or J because it's almost like if every programmer uses the same thing, right?
Convention.
It's convention, yeah. It's convention. So if I look at someone's program and they do a for loop, they're more likely than not to use I as the variable in that for. And it just makes it easier when you're reading the code. That's it, pretty much. You can name it whatever you want, but in this case, we're just going to do it that way. So we're accessing every item in range of our horizontal division, and then every item in range of our vertical division, right? So that at index 0 of this, so the first box on this side of the list, I access every single one on the vertical, so I go like this, until I exhaust it, and then move on to the second one. And then for every single one of those boxes that I'm now going through, I'm going to do something. I'm going to create our panels. Does that make sense? Cool. All right. So we're going to create the panels. Got our ranges. Right. Okay. This becomes interesting. We need points in order to create panels. Right? Our panels are made up of, each one of those things that we're creating is made up of 3 triangles. Each triangle is made up of 3 points. Their points overlap sometimes, so that's why we don't have 6 points. Point 1 would be equal to SRF, so our surface, dot point at, open brackets, I divided by unum, comma j divided by v number. Close brackets. What does that mean? What does that mean? Venture a guess. Let me zoom out a little bit so you can see it. The whole thing.
You're going to go like more width on the surface on the shifted.
Where? How can I decide where the point is? I can access a particular version of it, right? All I know is that I am within that area, I and j, right? By doing I in the index divided by the amount of numbers that I have in the division. It's quite interesting. This is just to signify where my point is within that box, basically. And it's in reference to where, to the total amount of divisions, so the point is placed there. So it's surface dot point at that point. So it's creating a point at each one of those. We do the same for 5 points. Each one of those points is slightly moved across. So this one is, it moves on the horizontal and a little bit on the vertical. This one moves both on the horizontal and the vertical. A little bit on the horizontal, a lot more on the vertical, and a medium on the horizontal and a little bit on the vertical. So I'm just creating where the location of these points are, so then I can join them up. We can change these however we want, and you'll see it will completely change the panels that we create. But it's just referencing where they are at the moment. And because we're dividing it by unum, why are we dividing it by the 2 amount? Because we don't want the panels to exceed their boxes. Okay? If we didn't have this division, then this would be moved about accordingly. If we have the division, it means that they stay within that box. And because we have a complex surface and that box is shifting constantly, right? If it's a square, it's very easy. If it's not a square and it's manipulated like that, that movement of 1 to the right, which we're doing here, means it has to do multiple mathematics in order to figure out what that means by dividing it by the surface. It's very difficult to explain.
It's just coordinates. You're just moving coordinates around.
I'm moving coordinates,
in a bounded space.
I'm also putting boundaries within those coordinates. So they don't exceed in a certain dimension. We can exceed them in the z dimension. You'll see that happens a lot when we change some of these numbers. Because I'm dividing it by the number, the total number. And then I and j are in reference to that coordinate.
Because that's how we, you'll see, you'll see. Let's not jump the gun yet, but you'll see.
Right, okay. Now, this is just where we're placing the points. We also need to do one more thing. Did you guys copy this, by the way? Yeah. It's pretty much the same thing, just add a little bit something at the end. Just copy the PTs here.
So I should change this to.
Yeah, yeah. Well, not yet. Just that. But I want to do other things. Guys, did you write it down? Just copy it. Not everyone has. Yuri, you got it? Nothing happens yet, don't worry. There's nothing that's going to happen now. Yes. Can you see down here? This is where we're creating the point panels. At the moment, it's just setting up the points. Yeah. Right, okay. Yeah, we'll let them finish writing this part. Right. While you're writing that, there's 5 more variables that we need to create. N1, N2, N3, N4, N5. Which is basically the normal. Normal is the direction facing exactly perpendicular to where our surface is. And we want to get that for every single one of the points that we're creating. So we're getting the normal you see in every single one of those points. So N1 is equal to the normal at point 1, N2 is equal to the normal at point 2, N3 is equal to the normal at point 3, N4 is equal to the normal at point 4, and N5 is equal to the normal at point 5. There's a reason why we're doing it, because the normal gives us the Z value.
Do you know what normal is?
Explain it to us.
So if you have a surface
So that your computer, it's a line coming perpendicularly from that surface.
Upwards.
Well, it's perpendicular.
Yeah. So if the surface is on the ground, then we do it upwards. Right? So because our point this is a complex geometry, right? So at every point, might be coming in different directions. So the normal of this direction is different. So we need to get that everything on the point.
Good. Well, I mean, if you, for game particularly, you don't like texture both sides of the surface, which way so the normal determines which way the kind of surface is facing, as usually it's camera. And so you use it for that to say which side of this surface, for the surface to, am I affecting, right? Or manipulating, or wanting to see.
And you can see why that's useful. Z direction, it wouldn't be this way. Right, so we have our points. Keep writing, by the way. I'm just saying, we have our 5 points. We have the normals of those points, which will signify a way in which we can move in the Z direction, so the 3 dimensional. And then we'll do something cool. Change them as you wish. You can change them as you wish. You can create your own, you can manipulate them, do whatever you want. At the moment, just copy them as there is, and then we'll play around with them and change them as we see fit. Yes? Okay. Yes, okay. Ready? Oh, you serve through the capital, then you don't have the and it's not, yeah, it's fine. So you code in what language? Bash.
Bash. I know quite a bit.
Just
What district?
Fedora. Want to jump in from one to another, like Fedora.
Same. Yeah.
I've never used
That's actually seven.
Well, basically, if you jump into the next turn, you'll go right to it.
Oh, yeah.
Yeah.
Same with PowerShell.
Okay.
Or whatever.
I have no idea about the syntax.
Mac uses Bash as well.
Is it? Oh, then I use Bash. But I don't know how to do it. I just copy the commands that I want.
But it's kind of like you can call Bash when you're just using your terminal kind of thing, but at the same time, you can do like scripting in Bash. It's a little bit different, but the principles are basically the same.
So the principles are always the same in any language that you use. It's just the syntax that changes, doesn't it?
Yeah.
They all have for loops. They all have if statements. Okay, some of them have some peculiarities.
At the kernel level, though, that's a bit more.
Yeah, like C#, for example. Now we're going to see C#. When you don't have when it runs a script, it can have global versus local variables. But in Python, it's a little bit. I don't think you can do that.
Yeah, you can. I mean, variables like that.
Technically, but if I in Grasshopper, if I set the variable at n equals to 0 in C# and run it in a loop, in a sort of interval, you won't reset it every time from the interval. You'll change the value of n if the script changes it and maintain that as a starting point automatically. Whereas in Python, you'll always reset those values every time. I'll show you an example of that. I had to find a workaround for a loop.
Yeah.
You'll see, you'll see. Right, okay, so everyone wrote that down? Yeah? Right, let's move on. Now that we know, now that we have our points on our surface, remember we want to create these panels based out of these 3 points, so we need to move them on the Z dimension. So that's why we needed the normals at those points. But now those points are useless. We're going to update them and create them in a sort of Z direction, so they move outwards of our surface, right? So just So what we're doing is pt1 plus or equals n1 times 0.2. It's basically updating the location of these points relative to the normal. So it's just moving them on the z direction. So we know where they are on the x and y, right? And if our surface is complex, let's say this one's pointing that way, perpendicular normal, it's just moving that point further outwards. So I can create a panel over it in a three-dimensional environment. Okay? That's all it's doing. That's
And the numbers, they're just random.
the numbers is just so it's not far out too much or whatever. If you change these, you'll see them poking out. So it's you can play around with it. We'll play around with it. But at the moment, just copy what you have here. The logic is what it is, right? So those points that were just on our surface are now moving in accordance to the normal at that point outwards. So I can create a three-dimensional panel.
You do it fractional to I if you wanted to control.
Yeah, you can do whatever you want, really. So that's what that is. And then if you move a little bit further, if you move a little bit further down, and it's almost done. It's almost done. Okay, this is it. This is the last part. All it's doing is basically creating a panel using Rhino geometry to NURB surfaces, create from corners. So it's creating a surface out of corners, which is move it to the right a bit. No, that's not.
Other way.
Yeah, and expand this.
Which this?
Yeah, just expand. Just expand the Python. There you go. Cool.
Can you maximize it? There you go.
Anyway, yeah, so the panel is equal to rg.NURB surface.create from corners 52, 53, 55. What it's doing is basically creating a surface from these 3 points. That's all it's doing. All right? Yes. Why is it pt1 plus equal? Because it's incremental.
Oh, yeah, it's the same as writing.
The same as writing pt1 is equal to pt1 plus whatever that is. So every time you run the loop, it incrementally increases that number because it's moving across. No. pt1 plus or equals n1 times 0.2. It means that incrementally, it's moving that point across. So it's explain.
What are you looking to do?
Okay, I got it. So, how do you move something in terms of a point? It has 3 dimensions, right? X, Y, and Z. In order to, what's the point X, Y, and Z is, let's say 3, 4, and 5, right? Now, is that position 3 on X, 4 on Y, 5 on Z, right? If I want to create a new point or even change that point, I have to change the X, Y, and Z values. But I don't want to change the X, Y, and Z values to what they were beforehand. I want to change the X, Y, and Z values to what they were at that point. So I'm doing whatever that point was. So it was 4, 5, and 6, plus whatever this is. So our normal would be another point times 0.2, so I'm just expanding the value. Hence why you need the plus. You can just write it as, well, you have it there, yeah. So when you put I, pt1.
Yeah, but that's applicable for everything.
Okay, whatever. So instead of doing class equals n4 times 1.3, you could just do pt1 is equal to pt1 plus that number, right? But this is just shorthand class equal. Class itself plus whatever. Please don't write this part. Actually, it's a good time to. Yeah, it's option 3. So if you use a hashtag, it basically just doesn't have enough light. Here it's just commenting out. You go to the.
No, it's just,
I don't know how to take it.
nice.
Whatever. Right, okay, so, right, once we have updated our location of our points, we're adding this, we're creating these panels using those points, and we're appending the panels in panels. Panels is our output, so instead of A, it's actually called panels in this one. So if we go back to our, with our script here, you see the output is actually called panels. Right? If it was A, then all you have to do is just say A. But you just have to say A is equal to an empty list up here before you do that. In this case, we just said panels is equal to an empty list because we renamed the output into panels. And we're just saying panels dot append panel. So it's just creating different panels and appending them in that list. That's all it's doing. All right, and that's it. It's going to run through every single one. It's going to get a point that's relative to that box. It's going to get the normal of that point. It's going to move the points accordingly, create surfaces out of those points, and then append them in the end. So in the end, you will have all those panels nice and tight in your set. I don't know what way to do it.
Wait a minute. Maybe to make it more correct, the language. Okay. Do you have a notepad?
Yeah.
Okay.
I don't know. I just use PyCharm.
Oh no, like a text.
I know. Probably somewhere. I think it does. Just Notes. It's called Notes, something like that. I don't really use Max much. Just anyway. Right. So once you write that down and press play, you should technically. I'm gonna make this a bit smaller, and I'm gonna minimize it so we can manipulate things. You should technically now have created your surface, your panels for the surface. And then if we change things like, I don't know, if we change the normal amplitude of something, press play, look at that, it starts coming out, right? Does that make sense? So now I can manipulate and change our panels accordingly. I can even change the points here to create the way that they combine differently. The way they're combining now is just so that they create three surfaces, one like this, one smaller one on the side, so the bottom one is free. You can see it here. But if you want, you can manipulate the points accordingly to create whatever surfaces you want. Cool. Right. Everyone happy so far? Yeah, you created your first weird shape. Let's do something a little bit different. Yeah, this is gonna be interesting. This one. Okay, so you see our little guys down there? There's some little guys down there.
Yeah?
If I press play here, I know this doesn't seem very exciting in terms of the geometry we just used, but creating a temporal simulation in Rhino Grasshopper is quite an achievement because it runs everything and
it doesn't have ticks.
Oh, it's just going.
That's cute.
Indefinitely. Oh.
Indefinitely. Right, okay, so.
You're using a plugin?
No, I'm not using a plugin, I coded it.
Look at you.
So that's the fun part, right? I'm not using animal or anything like that. Nothing you'll see here uses a plugin, right? It's just coded. Now, This is what I was saying about C#, much easier.
Is it? Yeah.
But I had to figure out how to do it in Python, so I was like, okay, let's do it. Right, so I'm just gonna quickly reset everything. See our little guys there. So what I'm doing here, basically, right, okay. So there's two specific Grasshopper scripts that are working. The first one is used to loop things around.
Is C++
Okay?
possible?
So how do I loop things around in Grasshopper? Now, if I want to add steps into a simulation, so something moves over time.
No, it's gonna entangle.
There's a few things you can do. When you're coding outside of Python Grasshopper, you can say that this thing moves there, then the next iteration goes from there to somewhere else, and then from that to somewhere else. In Python, in Grasshopper, things run in an instance. You can't do it unless you bring in plugins like Animal, which allows you to loop back data that you've already run. Or you do what I did and create a counter which runs at a specific interval with an increasing number. And then, as the number increases, things change relative to that number. Which is what I've done here. Now, so the first part that I have is a very, Reggie, look at the C# script. All I had to do was say that
That's brilliant.
n is equal to 0, and if reset, so if it's true, you just basically reset the number. Otherwise, you run it until you put a cap, which is x, and just increase the increment, right? And it works. It just does it automatically. You want to see what I had to do for Python? This is the fun part, right? So same inputs. So reset is just a reset button, which toggles true or false, and basically just resets everything, right? Now, run is true or false again. Basically, you either run it or you're not running it, right? So it's where you're signifying whether you want this to run. The speed, number, forget the number of days. It's just something that calculates if I want it to run on a 24-hour basis, the number of days that I want it to run, and then translate that every minute is, just basically create the temporality into a minute. So you can look at people moving, let's say in a city or inside your building with some kind of options at a minute-by-minute basis. It's just,
But like condensing that time.
condensing that time, yeah. So 1 second equals to 1 minute, or 1 second equals to 1 hour, or whatever it is that you want to do. And this is just resetting the script so it runs at an interval. It's not that difficult, but basically, it's what happens afterwards. I had to record the data and then move on.
Oh.
Basically, in order to do that, I would say that, what does if run? Run is a boolean. What does that mean? If it's true, yes. If run is true, so if my total for run is true and y is less than x, y. Sorry. Let me move this aside. Okay, this is unnecessary. Why is like that? Y starts with 0. Okay, so sorry. Y is 0 to begin with. So if y is less than x, right? And then y is equal to y plus 1 and a is equal to y. At the same time, I'm recording the data, which is basically I'm recording y, and then feeding it back in to the recording. If I move the recorder down here, whoop, you'll see what it does is it adds up every time this runs. Basically, you'll give me an answer that y is equal to 1 or that y is equal to 0 if I reset it. Now, every time it runs, it goes y is equal to 1, y is equal to 1, y is equal to to 1, y is equal to 1 every time I run the temporality. So I need to record that data and add it every time. So if I do a math addition, it means that if you look at the panel here, right, and I press play, it is here. Look at that. It's going upwards. Let me zoom in. There you go. See? And I can change the speed at which that happens. Now, why is that cool? It's because if I have a number that's constantly changing without me having to input anything, it means that I can tie that number to something happening. In this case, that something is a movement of people, right? So if I was to, I'm just going to pause it for a second, because it does take a little bit of computational power to do so. And let's delete the data from the recording. Actually, you know what? I'm gonna run it for a second so we have some data. Okay. Just stop. Fine. Right. Now, that whole numbering thing, that connects to another script, which has let's do that. This is the number of. There we go. This is 10. Just leave it there for now. So, there we go. Okay, so we have a number of points. Let's close that down. And let's minimize this a little bit. So we have a number of points you can see there, right? We're fitting into this new script. That's x. Y is the number that's constantly going up when I press play, right? As an input. And then we have z as just a slider. So what are we doing? Well, I'm creating a class. I have 3 outputs, by the way, A, B, C. C is an empty list. Class is, how do I describe class? You're a human, right? You're a collection of attributes. You have eyes, you have hair, you have 2 hands, you have 2 legs, right? At the same time, those eyes have colors, that hair has length, color, and other attributes, right? So how do I store that into one entity or cube? I create a class. So a class allows me to add a ton of attributes to one aspect. In this case, I have a class called person, and the only thing I'm adding to that person is their position and their ID. Right? I'm giving you 2 attributes. So it's kind of like an extended variable, if you think about it. So that person has a position and ID, and it has the ability to move at random. So I'm creating this crazy person that has a position and is able to move at random. It's for I in range of y, which y is what's changing constantly in our timer. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm constantly updating that, because if I have it running for I in range of whatever the endpoint would be, let's say 24, what it will put out is the location of that person after the end, after the 24 steps, right? But I don't want that. I want to see how he moves about at every single point, right? I want to see how that person moves and what trail he leaves behind. So I'm changing y constantly, and I'm using that a for loop in our code to signify that at a given range, this is what happens. Now the random.seed, I know it sounds like it's random, right? It is, but when you have a random.seed, it means that everything that's random at that point, and seed it's basically, so if I was to throw a dice, right, and I throw 6 the first time, 5 the second time, and 3 the third time, right? If I say random.seed1, it means the first instance of the first output of my first random, it will always be 6. It's not randomizing all the time, it's just running a sequence of random events, but stable random events.
Yeah.
So if I was to run the range and change the range all the time, previous iterations that have to run the random element are stored within that seed. So it's always the same. Otherwise, it'll just be floating about differently every time.
Computers can't actually generate random numbers. They just have an array of numbers that they select from, and that array, or an array of an array, and the kind of list of random numbers is just a selection of one of those. That's quite a fun topic to delve into, how random is generated.
Yeah, but random seed allows you to maintain that if, let's say, his movement was between 0 and 5 in the first step, right? And you move 4 points in the first step, and then 3 points in the second step, and then 5 points in the third step. If I change the range, those initial points in position 1, 2, and 3 stay the same. So as the range increases, previous steps maintain the same thing, so you can still see them as the simulation is running. Then I create a vector, which I am adding. So the vector is the movement of the person. Vector is basically, if you draw this. Vectors have magnitudes, right? So if I am stationary here and I'm in an XY position, if I have a vector of 5 and 4, right, that means that I have a magnitude of movement of 5 meters that way and 4 meters that way. But if you combine them, it's there. Does that make sense? Now, vectors are 3-dimensional as well, like in this case. So it's not just x, y, but there's a z value, so we move whatever those values are. They could be minus, so we can move backwards. They could be plus, so we can move forwards. Okay? Yes, so vector here, I'm setting up the direction. The direction is random between -5 and 5 in all directions except for the z, which is actually 0 and 4. So it's always moving upwards. It's just moving left and right as it's going upwards and forwards and backwards. And then their position is obviously their current position plus the vector. The current position changes every turn, right? So it's just adding up that vector. And then I'm appending a line from the current position to the new position. So I'm drawing a line so I can create that trail as it moves along and just storing it in C. That's pretty much it. So it's pretty self-explanatory. Like, it's very easy to think of it in steps. Of course, the coding becomes a little bit more interesting. And then I create, obviously, person is just the list of people that I'm going to create. A, B is empty lists, and I create a for loop, a number of for loops. For I in X, what was X again? That's X. Hang on. X is my point. Yeah. For every item in X, so for every point I have, I'm creating a new person based on where that point is, right? And then I create a counter. I'm not sure why I created a counter there. Person right next to person, append person, brackets X. That's right. Oh, the counter has to do with the index. So I'm adding that person based on the index of that. So I'm giving them, because I need to give them the position, I have to give them the index of that in order to give it the position, the point. Yeah, so I'm just using the counter here. So every time it runs X, it starts from 0. The first time it runs it gives me the first point. And then the second time, because it adds 1 to the counter, it will go counter is equal to 1, so it gives me the second point in the list, and so on and so forth. It's just a way of making sure that the right person is given the right position to start with. Then I do the same thing here. I add another counter, and for I in persons, for every item in my list of persons, which I've created above, so person over 10, I make them move at random. And then move at random requires 2 aspects, which is counter plus z. What did I add here? Oh, the random integer, yeah. So basically, So basically what it does here is telling me which person to move, so it's moving over the person. The Z, which is 10, is the seed number. So I'm maintaining the same seed number at every single one. I can change the seed accordingly, so you can have different passcodes. That's why I did that. And then lastly, for I in person, B dot append ID. Okay, then I'm giving them an ID so that when I zoom in, I can tag them to see who they are. So person 1, person 2, person 3, person 4. But okay, it seems a bit complicated, but all it's doing effectively is creating a list of people that have a position and making them move depending on what the number that's coming in, that's constantly changing, making them move a direction that's random on the X, Y, and random on the Z, but positively random on the Z. So it's always moving upwards. Right? Now we can change the logic. We can tell them to move within a confined space. So if they are to move past a wall, for example, they would have to change direction. So we can add different elements here. So we can test circulation. We can test what they can see as they move through the building. So at each point, we can draw lines until they hit an object. So we can see how much visibility there is in that building. So you can do a lot of things with a simulation like this.
Could you generate you make a graph in Rhino?
Yep.
And then put it into Grasshopper, assign it to Grasshopper, and then use it in input so that they can possibly they can never escape the graph.
Yeah. Yeah. You can have them detect if they are to hit a if the movement that you're doing exceeds the position exceeds outside bounding box, then you can get rid of the change direction. It depends on the logic that you put, right? Yeah. It's up to you to define the logic, but in this case, I'm just telling them to, in a very simple way, just randomly move up. And if I was to change the seed number, which I was telling about, why is it important? So, where are you? Here. So if I was to, you see on the left now? This is the random generation of the pattern, but as long as it stays the same, they always keep going upwards in the same way. If I change the random generation, it completely changes the pattern. So I think that's several iterations. Yeah, I can just tell them to move in a certain direction all the time. I can tell them to move in a certain direction until they hit something. I can tell them to move in a certain direction until they hit each other. Or I can tell them to move in a certain direction until they're close enough to each other, in which case they're repelled. Or I can make them move in alignment with each other. So there's one person moving, and then the group kind of aligns with it. So flocking, swarming, I can do whatever I want. But you're able to do that in Python only, not in Grasshopper. Unless you download a specific plugin. Which is kind of fun. Right. Does that start to explain what you can do here? Makes a little bit of sense? Yes? No? A little bit?
You're just changing a variable and then linking a position of an agent. Or agents to that, yeah. Or the coordinate.
So where's my 60th? Hands up. Do you understand it? This is literally the dumbest agents you're going to have to make in Studio 2. The aim is to make intelligent agents. So that means that the logic that which you're going to code is much more complex than this.
And better written code as well.
But this is a way of going about iterating and simulating intelligent agents, right? In a temporal manner, so you can record it and show it to people as opposed to just the outcome and you go, but how does it work?
You could, for example, add eyes onto it that looks ahead and sees the same geometry. If it does, then this way. Rather than relying upon you check in if the coordinates match this forward. That's an example of maybe into the person.
Yeah, I mean, I had a script where we haven't done recursive function. But I had called a wandering turtle algorithm, similar to this. It just wanders around in an enclosed space and creates lines. And those lines are used as the inputs of my primary roads. And then I was subdividing the surfaces that they were creating afterwards to create plots and so on and so forth, all in one Python script. So every time I run the algorithm, it creates another random set of primary roads, and I could test a whole new city layout and its performance. But actually, I have here.
Yeah, right.
Check it. Yeah. Hang on, one sec.
I mean, the coolest is head up to a set, right? And so if you can get into the loop of that, you can then add in rules for how why the logic is that to you. But there are simulations where you'll have, let's say, 30 points and then two of the different classes, say, friend and predator, and friends with friend as a group around, and that determines how groups and why groups, whether they kind of get away. You get quite complex with it, using just really simple rules. That also takes a long time abstracting complex interactions and relationships into life and code.
Okay, let's go for the top. So you can see here I have my urban form, for example, and I can create a little. What? Zoom in. Where is it? Ah, there we go. This is my wandering turtle. And every time I run it, it's creating other primary roads, right? And then I can, if I go to the other script, the other Python script, sorry, that's not it. It is down here. There it is. I can easily change down here. Z. Oh, I have it as an input. Cool. So I can easily change this number here, Z, to let's say 2000, and it will subdivide the surfaces until I get plots that have an area that's not bigger than 2000. It automatically does it. And then, of course, you can set certain rules on how to. Hang on, let me do the perspective. There we go. You can set certain rules. I have too many things open, sorry. Let's just go to the end so you can see the outcome. What did it do?
So a recursive function here is we're taking the output of one function as the input variable.
That's my.
So as you say, you solve that the limit of the iterations of the values.
Yep.
But you can let them
and then this is essentially my city that I've created, and what it does is it extrudes the buildings. It's not particularly clever, based on the surface that I've created above. So I can create a gradient with how I want to sort of extrude. So I have a city that's going downwards in terms of height.
Turn it upside down. This is sitting on a hillside.
Yeah, or it's sitting on a hillside. The point is, I can just change something very quickly and create a whole city in seconds because it's all set up, right? It's all set up and runs automatically. That's the beauty of coding in Grasshopper and Python, is the fact that you're creating these things not to get one solution, but the fact that you have millions of different solutions that you can then based on a set of performance criteria that you set. Right, so if you're creating a Python script to get one output, then maybe it's not worth it. Maybe you just draw it. But if you're creating a Python script so you can optimize, change, alter, generate a whole bunch of solutions because there's conflicting performances that you're looking for, daylight versus depth of the building, and so on and so forth. I can't think of anything else at the moment. But they are conflicting, right? So you're trying to balance between them. Then having a generative algorithm like this, which uses Grasshopper and Python, is way more useful. And it doesn't have to be on a level. For example, the times that we created, right? You can switch the inputs of the Z values, the multiplication of the normal, with inputs with the script, and then connect those inputs into Galapagos. You don't know what Galapagos is? It's the algorithm that's embedded in Grasshopper. We can also then run our output into Ladybug to test how well it performs in terms of its daylight rating or radiation analysis, actually, probably. And then if we want to maximize or minimize the amount of radiation that's hitting the surface, depending on the size of the quantum location, you'll completely manipulate the values of the script until it finds the best performing aspect. And that's the beauty of analytic design, right? You're doing it so you can work and optimize, or at least try and optimize for the solution. All right, hope that makes sense. All right, kind of fun, right? You guys enjoyed it a little bit? I know it seems like a lot, and of course you have ADD being able to help you every step of the way. You want to create something in Grasshopper. We didn't have this, by the way, when I was a student. So Reggie's working on Wednesdays. He's probably one of the best people to go and see to help you with this. So if his Wednesdays are not fully booked, there's something wrong.
I'm doing Unity in 2 weeks, maybe Google. So we're using C#, but
yeah,
it's just different
logic is
syntax
the same.
of what we've logically done today, but specifically using game engine, with this game engine to make import like a model and then walk around in it and then upload onto a web. So say if you had a web portfolio, you have to be able to have your 3D model that you produced, not just flat drawings. This is your website to walk around in it and get offer you a job. That's part of that.
Cool. Anyone have any questions? No? You want to play with it? Great. Well, I hope you enjoyed it. I know it was a bit long and some of the things were like, why are we doing this? But hopefully, when you guys start thinking about something to create in Grasshopper, if you hit the wall in Grasshopper and go, I'm not entirely sure how to do this, or I can't do this in Grasshopper, you can call back and say, you know what, I can code it in Python. Or attempt to code it in Python and then come see me or and say, please try and help us to code this
Just
in Python. But Jason might be able to help as well, actually. But, yeah. Cool. Thank you very much, guys.
Thank you.
I was